In this video, we're going to learn how to determine the nature of a quadratic graph by looking at its roots. Now, this is sometimes known as finding the discriminant of a quadratic equation. Now, there are three different options that we can really have, and you'll notice I've used the positive x squared graphs in each of these cases. The same effect would occur with the negative x squared, just that they'd be upside down. So, we can have ones where they never touch the x-axis at all. These are known as having no real roots, because they do not cross. It crosses the 1, so that's just one real root. If you're using factorising, that's known as a repeated root. And over here we've got one where it crosses the x-axis twice, so this is known as having two real and distinct roots, distinct just meaning different. Now the way in which we can determine what shape we're going to have here, whether it's going to be no real roots, one real root, or two real and distinct roots, is by contemplating the quadratic formula, which we discovered in a previous video. Now, in the quadratic formula, there is one bit that stands out, and that is this bit here. It's the square root of b squared minus 4ac. Now, the reason this stands out is because there's certain values that we can have here that will work, and some values that won't work at all. We know, for example, that anything that's under a square root has to be either 0 or greater than 0. If you end up with a negative number under a square root, it doesn't work. So from there, what we can say is, well, if b squared minus 4ac ends up being less than 0, i.e. a negative number, there are no real roots. Similarly, we could say, well, if b squared minus 4ac is equal to 0, well, that kind of helps as well, because the square root of 0 is just, well, 0. So if we did minus b plus or minus 0, it just gives you the same answer, regardless of whether it's being added or minused. So we can say then that if that gives us the same solution, that means b squared minus 4ac is 0 results in one real root, or repeated roots, because you are repeating the same sum regardless of whether there being a plus or a minus. However, if we use b squared minus 4ac is a positive number, well, using the square root of 9 as an example here, if we take the square root of a positive number, we end up with a positive and negative result. So there's two different solutions to this here, which means that when we put it back into here, you've got this, whatever this number might be here, plus or minus a value, which will result in two different results in terms of your roots. So if b squared minus 4ac is greater than 0, this means we've got two real and distinct roots. Okay, so we're saying that this one here results in a graph looking like this up here. We're saying that if it's equal to 0, we've got a graph that looks something similar to this. And if we've got it being greater than 0, that means we've got a graph looking like this one over here. Okay? So what we're going to do is a few examples. So the first one we're going to look at is the roots of y equals x squared plus 5x plus 4. And for those of you a bit more eagle-eyed, you could probably work out straight away this is going to have two real roots because this can be factorised. But we'll just show that anyway, okay? So using a similar method to what you did for the quadratic formula, we know that a is 1, b is 5, and c is 4. Which means if I stick it into the formula, b squared minus 4ac, I'm going to have 5 squared minus 4 times 1 times 4. 5 squared being 25, minus 4 times 1 is 4, times 4 is 16. 25 minus 16 is 9. And we can see quite clearly that is greater than 0. So greater than 0, let's just double check that. If we were greater than 0, this is two real and distinct roots. So just to finish this off, therefore, two real and distinct roots. Now, because the question is saying just determine the nature, we don't actually have to find out what these roots are. We don't really care that much. In examples later on where you try to work out whether you're going to have to use the quadratic formula and you've got some really nasty numbers in there, it's sometimes handy to work out what the discriminant is first to see whether it's going to have roots in the first place. If you know it's not going to have any roots, there's no point in doing the quadratic formula. But in this case, just for these basic questions, we're not asked to find the roots. Okay? So next example, we've got y equals 4x squared plus 4x plus 1. So again, this time a is 4, b is 4, and c is 1. So from there we can say b squared minus 4ac is equal to 4 squared minus 4 times 4 times 1. 4 squared 16 minus 4 times 4 times 1 is 16. And 16 take away 16 is 0. Right, okay. So if it equals 0, b squared minus 4ac is equal to 0. That means we have one real root, i.e. a repeated root. So we can write that down straight away. Just at the end here. Therefore, one real root, or repeated roots. Okay. And the third example, well, you can probably guess. We've had one that's greater than 0. We've had one that's equal to 0. So no harm in guessing this is going to be less than 0, 1. But we have to prove it anyway, guys. So a equals 5, b equals minus 7, and c equals minus 3. So we've got b squared minus 4ac is equal to minus 7 squared minus 4 times 5 times negative 3 equals 49 minus 4 times 5 is 20 times negative 3. Oh, minus times minus is plus. Right, 4 times 5 times 3 then is 60. And I've caught you all out. 109, which is greater than 0. It's greater than 0 then, so that means it's 2 real and distinct roots. Okay. Well, I can change that around just to make sure we do have one that's going to be negative then, a negative overall. If you just change that into a plus, we'll end up with example 4, y equals 5x squared minus 7x plus 3. So basically we're using the exact same as we did before, just this is now a positive 3 instead. So a is 5, b is minus 7, c is positive 3, and we'll have b squared minus 4ac, always write that formula out, minus 7 squared minus 4 times 5 times 3. So we've now got 49 minus 60 is minus 11. Minus 11 is less than 0. That's the only one that we've not used so far. It's less than 0. We have no real roots. And I know what you're thinking, well, what do we mean by real roots? Does that mean we've got imaginary roots? Well, technically we do, but you will not see that until a much further advanced part of the course, okay? So this is not going to be part of the National 5 course. We'll look at imaginary numbers later on, but for now all we really care about is the term real roots. One last thing, please make sure you are stating these as your evaluations. If you do not state them, then you will not get the marks in a final test or a final exam. So look out for some examples. I'll see you in the next video. Thank you.